let's talk about machine learning then. Okay, so in the previous session we talked about those high-level services, and they're super easy to use. They work very well on general-purpose problems, but of course sometimes you just have to train on your own data, right? You have to. You just can't work with recognition because you have specific images, or you need to build another machine learning model beyond what those services support. So we're going to focus on the middle layer here. So yeah, we're going to talk about most of this stuff, not all of it, but most of it. And I'm going to show you a number of examples. Okay, so we'll run some code. Before we get started, I think it's useful to quickly look at what the typical machine learning process looks like. Okay, so it starts with a business problem. Again, with the discussion at LX earlier today, it was pretty fun. You surely, if you're in consulting, or even in your own company, someone shows up one morning and says, "Oh, we need to go into machine learning." Yeah, it sounds like a Dilbert cartoon. We need a machine learning strategy. Okay. All right. Why? Okay. And my first question when meeting with customers who ask me about machine learning is like, okay, before we go crazy with machine learning, explain to me why you even want to get into this thing, right? Because if you can ignore machine learning altogether, you can live a good, healthy life, right? Yeah, trust me. Getting into that is, probably killing a few years of your life. So why do you even want to get there? Okay, what's the problem you want to solve, and why don't you think you can solve it with traditional IT, right? Write a Java app, have a MySQL or a Postgres server somewhere, problem solved, right? So you should really insist on that. Understand what the business question is. So the business question could be, I want to detect if a transaction is fraudulent or not. And we tried doing this, writing business rules, and it didn't work. So we added more business rules, and it didn't work. And then we scrapped all the business rules, and we added more business rules, and it didn't work. Okay, probably that's a machine learning problem. Or you could say, I want to know, I'm running a service, on an online service. I want to know which customers are likely to stop using my service in the next 30 days because I want to send them a marketing offer to keep them interested and engaged and maintain revenue. And we tried building this with business rules, and it didn't work, and it didn't work, and it didn't work. Okay, probably that's a machine learning problem too, right? If your question is, how can I go around silly European laws that prevent me from selling stuff in this specific country? I don't think that's a machine learning problem, right? And that's probably not such a good idea anyway, right? So my point is, you need to figure out what the question is, and you need to challenge the fact that, or not challenge, but you need to understand how this problem has been addressed before and why did it fail. Okay. And this is called framing the problem, understanding how to express the problem into something that data can solve. Okay. And this means talking to business experts. So for example, coming back to my fraud detection example, some people can look at, the IP address, the time of day, the user agent, the average basket for that customer, the number of orders they've passed in the last 12 months, blah, 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 and they say, that doesn't look really good. Right? That doesn't look really good. So you have to understand how they do it. Right? What are the data points they look at, and what's the thought process? So it really starts with interviewing business experts and understanding what data they use to answer the question. And of course, then you need to start collecting that data, integrating it in a central place, cleaning, filling missing values or removing outliers, etc., etc., preparing everything. And that takes a lot of time. And it's fair to say all of that is really big data. It's not machine learning, especially at scale. Cleaning logs, cleaning tables, etc. And then you can actually start doing machine learning. So you can start from the data set that you prepared, you can start building features, so high-level variables that are more expressive. Again, if you're new to machine learning, this sounds like complete crap, so let me give you an example. Imagine in your data set, you have customer addresses, right? And you want to predict sales based on customer location, okay? So, unfortunately, whoever wrote the schema and the app did something like one column with the street name, one column with the street number, one column with the zip code, one column with the city. So it's four columns. So of course the street number by itself doesn't mean anything. The street name is not so great, right? You could have many different streets, many streets who have the same name, etc. So you could say, well, I'm going to put everything together, so I'm going to build one column with street number, street name, zip code, blah, blah, blah. But that's not very useful because it's text strings only, and machine learning is mostly statistical, it needs numbers. So text strings, you will have to even turn that into numbers. Or you could say, well, maybe I can turn this address into latitude and longitude, right? Because I have a database somewhere or a tool that maps addresses to GPS coordinates. And you could build that, and that's probably a better feature to use, right, than street and text strings, okay? So that's an example of feature engineering, building higher level features, higher level columns in your data set that are more expressive, that store more information for your model. And then, of course, once you've done that, you can try looking at machine learning algos. Maybe you're trying to build a classification model, so you look at classification algos. Maybe you're doing something else. So you try different algos, you try different parameters, you train again, and you measure accuracy using a part of the data set. Most of the time it's not going to work very well. So accuracy is going to be very low, so you have to figure out why. Maybe you need more data, maybe you need to clean data more, maybe you need more features, maybe you need a new algo, maybe you need different parameters. That's a lot of maybes, right? At some point, you get to an accuracy that is good enough to solve your business problem, and that's a topic in itself. What's the accuracy that I need to solve my problem? If you're trying to forecast the weather in Ukraine over the next week, I guess 80% accuracy is very good. If you're trying to do cancer detection, 80% probably not so good, right? That's a lot of people who are either going to be told they're sick and they're not, so that's never good, and even worse, a lot of people are going to be told they're not sick and they are, so that's even worse, right? So accuracy depends on the business problem you're solving. And you deploy your model, and you have a live model, and your real problem starts now, because so far, right, all that stuff was offline, backend. You could break it 10 times per day, no one would care. Once you've deployed, you're serving predictions to mobile apps, web apps, business apps. Somebody will care if it's broken, right? So you're back to DevOps land, and you need to do monitoring and debugging and scaling and all that good stuff. And of course, as new data comes in, probably you need to retrain every once in a while to keep the model fresh. Okay? So that's very disappointing, right? Mostly I've been talking about big data, training infrastructure, right? Lots of servers here, and all kinds of crazy web ops stuff here to keep everything on, to keep that show on the road. Okay, when you thought you were going to do machine learning, right? And actually, it's a serious consideration. I talk to a lot of machine learning engineers and data scientists, and they tell me 50, 70, 80% of their time is spent doing this and this, right? So, and managing servers in the middle, right? Where really the only thing that matters to performance, machine learning performance is really this, right? Having the right features, having the right algo, and training well. So that's where you want to focus. This should be like an automated pipeline. This should be managed infrastructure, okay? And that's what SageMaker is about. So before we go into SageMaker per se, let's go to data first, because machine learning is about data, and building data sets is not easy. Okay? So imagine your task with building an autonomous driving model. Okay, so you need lots of pictures, thousands of hours of video, and for each picture you need to do something like this, which is called semantic segmentation. That's a fancy word. It really means taking each pixel in this picture here and assign it to a specific object. Okay, so this is a moving car, this is a stationary car, this is trees, I guess, not moving, right? Good news. This is the road, etc., etc. Okay, and you will train a model to on this data set, hoping that the car stays on the road and doesn't kill people. Okay, but I guess you need more than 3 images. So if you had a tool to do this, right, like a paintbrush kind of tool, how much time do you need to get from this to this? What do you think? Milliseconds. Wow. This man is a robot. Catch him. I don't know, 5 minutes, 10 minutes, something like that.
This is about this passing test. I'm not a robot.
Yeah. Yeah. Click on the buses. No, I just want to buy a plane ticket. I don't want to click on buses. Stop. Yeah, that's painful, especially for me. I spend my life clicking on buses, bicycles, and fire equipment, and driving me crazy. Anyway, so okay, let's say 5 minutes. Okay, imagine you have 1,000 hours of video, 24 images per second. Okay, 1,000 multiplied by 3,600 multiplied by 24 multiplied by 5 minutes. Okay, shall we start? Yeah. Okay. No. So of course that's painful. Okay. But even for smaller scale data sets, maybe your company wants to build a sentiment analysis model on customer emails or customer tweets or whatever, and maybe you have 100,000 of those, and you don't want the engineering team spending 3 months tagging those things, right? So we build a service called Ground Truth, and Ground Truth, I'll show you a quick demo, so I don't want to get into details too much, but what this service brings you is simple tools to actually do the labeling, so GUI tools that are easy enough, I guess. You can also dispatch the work to workforces, so it could be a private workforce. So all of you in the room could be in the private workforce, and you would connect, like I'm going to do in a few minutes, and you would start labeling images. Or we could use a third-party workforce. And there are actually companies out there that provide skilled workers to do this. Or if you need to go at large scale, you can use Mechanical Turk, Amazon Mechanical Turk, which is a task service where over 500,000 people contribute to all kinds of tasks, and particularly this, right? So if you need to scale it to a high number of workers, you can do it. And we can also train a machine learning model as data becomes available from humans and save time. So this is how it works. So you start from raw data. People start annotating, okay? And a model starts learning from that. Okay, it looks at those annotations. In a way, you start to build that data set, right? Yes?
Excuse me, is there any kind of quality control of what
yes.
the guys want?
Yeah. So the question is, what about quality control? So you have the option to send the same sample to multiple people, okay, and so that they will average the annotations over 1, 2, 3 or more people. But I'll come to that. Actually, how well you explain the task, I'll show you. How well you explain the task is important in getting the right quality. But you can send it to different people, and you'll see a confidence score in the annotation as well.
So is it built-in function?
Yes, yes. So as that data becomes available, we can train a model on that. Okay, and you can't really see my arrows because they're gray, and the light gray should change that. Okay, so this model will start annotating automatically. Okay, and it's going to compare its quality score to the human quality score. Okay, and if it's not good enough, then okay, it keeps learning as new data becomes available. Okay, and at some point, the quality from the automatic annotations become as good as the quality from humans. And so then it starts labeling at scale. Okay, so it really speeds up and labels at a very large scale. Okay, so, and it keeps comparing its quality to human quality. So this is how you build huge data sets, and you end up saving maybe 70% of the work by doing it automatically. Okay, there's no way humans are going to label 10 million images, right? Even if you have 100,000 workers, it takes forever. Okay, so you start labeling stuff, and then machine learning picks up. Okay, so like I said, you could have a private workforce, you could have third-party vendors, or connect to Mechanical Turk. Okay, so let's try an example. I'm going to do 3 images. Okay, so not much of a data set, but so I set up. Where's my console here? Okay, we can close all that. Okay, so that's the SageMaker console. Okay, so I created a workforce. It's not much of a workforce. It's me. Okay, so me, and I invited one of my colleagues who never even connected. Rick, I see you. Lazy. Anyway, no, it was just to test. You
can spam him if you want.
Yeah, I could send him an email and say, hey, I'm in Ukraine, and you look silly because you're not working. Anyway, I could invite new workers if I wanted. So that's my workforce. Okay, just me, pretty much. And I created a labeling job. So my labeling job is 3 objects, right? 3 images. And they're in Amazon S3, okay? And in this case, I would like to build an object or a guitar player detection model. Okay, so I'm not going to get the job done with 3 images, but okay, I'll show you how it works. So that's my job. It's been assigned to my workforce, and my workforce has a portal it can connect to. Hopefully that's still up. And this is all fully managed. You don't need to do anything here. So I can select that job, and I can start working. Okay, so it's going to present me with samples. And I give excellent instructions, right? My instructions are, please draw a box around guitar players, okay? So coming back to your quality question, this is very bad, actually. I should give more detailed instructions, and I should provide a good example and a bad example, like overlapping boxes, or, so you can, how much information you give to the people is actually very important in getting the right quality. Okay, so I'm gonna draw a box around that guy. I'm gonna draw a box around that guy. Okay. Okay, yeah, so I have 2 boxes, that's fine. I can see, yeah, it's, okay, yeah, you see the purple weird thing. Okay, so I have the 2 boxes. I'm done. Okay, move to the next one. All right, so is that a guitar? Yeah, that's a guitar. So, and if you don't know who these guys are, that's okay.
Can I
That's
ask
okay.
a question about the previous image? We didn't select there and then back to us with the guitar.
Yeah. Ah, yeah.
Is it correct or not?
Who knows?
Is it
My instructions are not good enough. Okay, and here's the third one. Thank you. So actually, you could argue that should we do it like this, or should we do it like this? You know, I would include the guitar personally. I think the guitar is interesting in knowing that this is a guitar player, right? But again, you probably would need to add instructions. Okay, so I'm done, right? And so it's going to crunch for a bit. I'm just going to show you the outcome. Yes, Seattle, I guess is fine. And so I get those labeled images. So in S3, I actually have a JSON file describing the bounding boxes with the coordinates for the image, etc.
Do you have 2 of them on the first image?
Because I didn't pay attention to what I was doing.
So
Yeah, the first one is actually missed. Yeah, it has 2 labels for no good reason. And I can use this information and train a model. Okay, so again, you can do this with and of course 3 images is not enough to do active learning. Use the machine learning thing, which I didn't set up, but you would just set it up by saying, hey, please train a machine learning model while you're at it. Okay. So that's, again, you can do, and if you, when creating a labeling job, you pick the task that you want, right? Image classification, bounding boxes, segmentation, text classification, or you can do custom stuff if you want to. Okay. So that's a cool service.
May I ask a question?
Sure, yeah.
You said about the then automatic labeling. So actually, once you label it the data set, you run through the model, right? You have predicted labels.
Yep.
And you compare them with the manual one, and if the accuracy is good enough,
Yep.
then you can learn.
Yep.
Okay.
So you see, if I'm going back to this, let me see, let me get to, yeah, this one, I guess. Okay, so I see, yeah, see the confidence here is very low because it's confused by the, not be a good one, let's take the other one.
Is it possible to see any metrics, let's say like learning curve, accuracy, false positive rate?
No, this is fully managed, so the model figures it out. Okay.
Because let's say, but how you decide, let's say, if the data set that you have is like enough? I mean, so usually you have this learning curve where you can test the training.
Here we don't care about that model at all, right?
So actually that's for the labeling.
The model is just for the labeling.
Okay.
So it's not going to be used for any prediction afterwards. Okay.
Okay, yeah, I got it.
So we just want to know that it matches the quality of humans, and that's it. Okay. All right. So now let's talk about SageMaker. So SageMaker is a combination of different modules, and we're going to see that. So the first one is about experimenting. Okay, finding the right algo for your machine learning problem. And well, we need a couple of things for that. So the first thing to make experimentation easy is we provide what we call notebook instances. So these are fully managed EC2 instances, pre-installed with Jupyter and all kinds of data science tools to just basically save you from installing that stuff for the millionth time. We also have a collection of built-in algos. So we'll get back to those. So Amazon implemented algos for typical machine learning and deep learning problems. And we also have environments for popular machine learning libraries like TensorFlow or PyTorch. Okay, so all that stuff is ready for you to use. You know, you can click on create a notebook instance, open Jupyter, get to work. No setup needed on any of those things. Okay. We also added a few features like Git integration, so we make it easy for you to access Git repos from notebook instances, so you can automatically clone your favorite repo.
Can you go back to the one slide? So regarding the frameworks, is it different, let's say, from simply running the VM on EC2 instance with all of the, let's say, buying the model from the marketplace with all the tools installed? Is there any benefits? Or like maybe
Yeah, the benefit is you don't manage the instance at all.
so just, and what about the price-wise? Would be more beneficial to use this kind of?
How much is your time worth?
Well, it's like only usually it's like several hours to set up, and then if it works.
Yeah, and if you need to do that, yeah, so I agree. It's a few hours to set up. So it's set up, and then you're happy with that instance, and it took you hours to set up, NVIDIA drivers, etc. Okay, and so what do you do with it? You keep it. Okay, so probably you leave it on. Yeah? Who systematically shuts down EC2 instances when they're done working?
Well, it depends on the case, but yeah, I agree that.
Right, so you're spending time setting that up. You're probably leaving that thing running for no good reason. If a newer version of TensorFlow or a new version of NVIDIA drivers come out, you have to upgrade, and that's going to break things. And
You actually can just download the new instance from the marketplace now.
yeah, you can do that if you want, but
You pay here only for, let's say, training time or prediction time?
so you pay for. So we haven't gotten to training yet. So you pay for the notebook instance like an EC2 instance
Okay.
Okay. per second per instance time. Okay. So yeah, you can manage Git. I'll go back to Elastic Inference later on. Okay. We also added built-in algos. I'll get back to that. The scikit-learn environment is actually new. And there is a model marketplace. So let me talk about that for a second. So actually, in the spirit of trying not to do machine learning, right? We built this model marketplace where AWS partners have trained models and published them. You may know the EC2 marketplace. So if you want your favorite security application or your favorite BI application, it's off the shelf in the marketplace, click, 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 deploy. Okay, so this is the same thing for machine learning models. So before you go and train stuff and spend months doing that, please take a look at those models. Maybe they solved your problem already. Okay, and you can deploy any of that in a few minutes, test it, run some predictions against it, and decide if it works or not for your business problem.
And what is the usual pricing model to this model? So it's like pay as you go?
So most models are free so far. You just pay for the instance running the model. It's like the EC2 marketplace.
You just, when you're talking about the model marketplace, so you also are renting the instance of EC2? Or you're just downloading the model and...
No. You run it, you deploy it on, you deploy it on the SageMaker instance. Okay, so you pay for the underlying instance. Some models they have a free, like you can test it for free for 2 weeks and then you have to pay. But most of them are free, yeah.
Is there some kind of a security check when somebody uploads the model?
Yes, yeah, sure. It's like again the EC2 marketplace. Anything that is pushed to this marketplace is validated by AWS teams. So there's no security concern. Okay, there's no security concern. Okay, so once you've selected an algo, so you've experimented with algos, and by the way, if you are into machine learning and you train cool stuff, why not publish those models on the marketplace, right? It's good publicity for your company, especially early on, right? Because we have about 150 models at the moment. At some point, we'll have thousands. So it's good publicity, and you can make some money out of that. So if you train models and you're happy with sharing the models, well, why not publish them, right?
Have integration with Cargo, let's say, easily?
No. But again, like I said, most of them are free for now. Okay, so once you find a model that you like, an algo that you like, and you trained, and it's okay, you experimented in Jupyter and it's fine. Now you want to train the real thing. So now you need to train on the full data set and get good results. So that's usually where the problem starts again, because you need training clusters, And if you want to train lots of models in parallel, then you need many clusters. And if you want to optimize hyperparameters, so find the best parameters for your job, more infrastructure, try all kinds of combinations in parallel. So it's complicated, right? So SageMaker makes all of this fully managed, and this is literally one line of code, right, as you will see. So we added some more stuff in there. We added new instance types. So if you're familiar with EC2 instances, you know the C family. C means compute, so compute optimized instances. 5 is the generation number. So basically the most powerful CPU instances on AWS. And P3 is the GPU family running the latest NVIDIA GPU. And the N means 100 gigabit networking. So if you run large distributed jobs, you know, the faster networking will help you save time on training. We also did some extra work like scaling TensorFlow linearly to 256 GPUs, but hopefully you don't need that much, and a few more things. And finally, once you have a model that you really like, it's been trained on the full data set, it works, then you can deploy it to production. And like I said, this is actually the risky part, because once it's deployed, if it doesn't work, if it's slow, if it doesn't scale, if it's broken, you start impacting the quality of service of client apps, and that's terrible. So again, we deploy on fully managed infrastructure, one line of code, load balancing, auto scaling if you configure it, and you get your HTTP endpoint that you can invoke to get predictions. Okay, or you can do batch prediction. You can skip the HTTP deployment and just run batch prediction on whatever data set you need to predict. Okay, so that's possible too. And we added some cool things here, but I will cover them later. All right, yeah, nice. Okay, so that's all that stuff here is new from reInvent. Okay, so like I said earlier, 200 features, 200 machine learning features in a year, and you know we're not stopping. So how do you work with this? So what I'm going to show you is a bunch of notebooks that use a Python SDK. It's a high-level SDK. It works with high-level objects, algorithms, and etc. So it's not very difficult to understand. It's available in Python. There's also, anybody uses Spark? Okay, so I'm not going to cover it tonight, but there is also a Python and Scala SDK for Spark. Okay, so if you're curious why Spark and SageMaker make a good combination, okay, ask me questions later. But it's a cool scenario. Okay, so that's the one I will focus on because again, it's very high level, it's easy to understand. Of course, as always with AWS, you could use the command line interface if you're that kind of person, or you could use the one of the SDKs in whatever language is your favorite. So Boto3 for Python, or the Java SDK, or the C++ SDK, or the PHP SDK. That's a scary thought. I'm sure we have customers who train in SageMaker and PHP. I wouldn't be surprised. Why not, if that makes sense to them? Not much of a PHP fan. So these are the traditional lower level SDKs. So to manage infrastructure, like maybe, I don't know, you know, create a training job or describe a training job, you know, that kind of operation, these work well. But for, again, experimentation and iteration, I would really recommend using the high-level SDK. It's much more flexible. So under the hood, and we don't really need to know this, but I think it's nice to know a little more. This is all based on Docker containers. Okay, so when I'm talking about built-in algos, built-in TensorFlow, etc., what I really mean is we have a collection of containers who are hosted in ECR, which is our Docker registry, and and these containers are just ready to be used. So when you are training, you're not really writing machine learning code most of the time. You will write, so it's hard to read, but this says helper code, and that's what you'll see in the notebooks. It's really a few lines of Python to select a container for that algo, set up some parameters, and then train. You'll be surprised how little code we write here. So once we fire up training, so SageMaker is going to create a bunch of EC2 instances, pull the right training container, load data from S3, train for a while. Once this is complete, training infrastructure shuts down automatically. Okay, so you stop paying. That's one of the cool features in SageMaker. You never leave any training infrastructure running. Right? It terminates automatically when training is complete. The model is saved to S3. And then you could grab the model and deploy it on your laptop if you want, right? All these models are standard models. They use standard libraries. Nothing is custom. And you could even have an existing model that you already trained and it works for you. So you could import it to SageMaker as well. And you could deploy it. Again, write literally one line of Python and deploy to a fleet of load-balanced web servers that serve HTTP predictions to your apps. Or, like I said, you can do batch prediction on a separate fleet of instances. Okay? So that's, in a nutshell, that's how it works. Yes?
When you say about importing, what kind of format? Do you mean ONNX, DML, or?
No, you can bring your TensorFlow model, you can bring your PyTorch model. The built-in algos are implemented in MXNet, okay? But no, you can bring a native TensorFlow model and deploy it, okay? There's actually, there are a ton of examples. I'll show you where they are. And there's actually, they call it bring your own model. So copy your model to S3 and then deploy it, okay? And so, like I said, you could train on SageMaker and deploy on SageMaker, or you could train on SageMaker, grab the model and deploy on-prem. You can import an existing model and deploy on SageMaker. It's an SDK, so use whatever makes sense to you and ignore the rest. So when it comes to training, we really have three options. We can use any one of the built-in algos. We can use the built-in environments, which I call bring your own script. Okay, so I have my TensorFlow code. It's running on my laptop. I want to train it at scale now. Okay, just take that code and throw it at SageMaker and then we're fine. Or if I have something weird, like R. Anyone using R? I'm not surprised. You look like an R guy. No, just kidding. Okay, but R is an example. If you have a C++ fancy prediction library, you can bring it here. You know, Java, anything. Anything that fits in a Docker container is gonna work here. So it's actually very easy to create that container. Just provide the entry point that SageMaker should call for training and prediction, and you're good. Okay. And yes, there is an R example in our collection of notebooks. So see, we're nice guys. So this is the list of built-in algos, and there's a complex color code here. So orange is supervised learning. So we train on labeled data sets, right? For maybe classification, regression, or a few more things. We have traditional machine learning, and we have deep learning as well. Image classification, object detection, semantic segmentation. Okay. So if you wanted to build your own version of recognition, right? That coming back to an earlier question, and you want to do object detection on very specific images. For example, I had a customer who was in the semiconductor industry, and they wanted to find defects on silicon wafers. You see the silicon discs, right? Where they burn the actual chips. So yeah, that's a bit specific for recognition to handle, to say the least, but you could do it here. Okay. If you have enough labeled images, right? So that brings us to ground truth. Who would be excited to label silicon wafers for a week? Yeah, they'd be interested in that. And then you have the yellow algos, which are unsupervised. So problems like clustering, anomaly detection. So you just bring a data set and you don't quite know what that data looks like, but the unsupervised algos will figure it out. Okay, topic modeling, which is exactly what we've seen in Comprehend. Okay, remember Comprehend building topics? Comprehend actually uses this algo here. So if for whatever reason Comprehend topic modeling is not your thing, and you want to train your own algo, you can do it here. Okay, so all these are implemented. They're used by Amazon internally, so they will scale, right? So if somebody in the team says, think we need to write a new linear regression algo, or we need to build a new clustering algo. Just find something heavy and drop it on their heads, right? Okay, there's no reason to do that. No one does that anymore. Okay, maybe Netflix does it, but okay. I'm not Netflix. Seriously, you would need a very, very, very good reason not to use these and write your own code instead. And the other gentleman has a question now. You should never have raised your hand. I'm going to pick on you now.
So how are they different from scikit-learn implementation?
Okay, I knew that was your question. I have psychic powers. So, the thing is, and it's a very good question actually. So the question is, how are they different from scikit-learn? So scikit-learn is a super, super cool library for machine learning. And actually, I'll go as far as saying, if you are just starting with machine learning tonight, the first thing you need to work with is scikit-learn. Okay, it's great. It has a super collection of algos. It's Python. The documentation is great. There are a billion examples. There's a nice O'Reilly book on scikit-learn. Right? That's your first step into machine learning, if you ask me. Now, these are great, but scikit-learn trains on one single instance. Okay, it's actually difficult. And somebody would say, oh no, you can distribute scikit-learn training. So sure, I mean, yeah, you can make a dog walk on two legs, but that's not necessarily a good idea either. So at scale, at a certain scale, scikit-learn is not the best choice. So of course, factorization machines are factorization machines. So if this implementation is the vanilla factorization machines, the theory, right, says that you'll get the same accuracy that you would get on scikit-learn using factorization machines. The thing is, all these algos are distributed algos. So if you need to train on 1 petabyte, which sounds a little extreme even for me. So 100 terabytes of data, right, you can do it here.
Okay, but how it's better than SparkML, let's say? It's parallelizable, but it's more a set of algorithms. But
sure. So it's better than SparkML in the sense that you don't even have to manage a cluster. How much work would it be to set up a SparkML cluster to train on 100 terabytes?
I can use Amazon EMR and spin it in a half of this.
Same as Databricks, so they have the cluster.
The same for Databricks.
Yeah. Well, sure, but here there's no infrastructure work, zero.
That's more question for the algorithms implementation more than infrastructure.
Sure. So, okay, I'm not going to go deep. I can share appropriate information. So we actually benchmark these algos against the best of the best that we could find out there. Okay, all of those, right? Especially these, right? I would say the traditional ones. They're generally 10x better, meaning they train 10x faster, or they scale 10x more, or they're 10 times cheaper, etc., etc. So these are state-of-the-art implementations compared to anything else. And again, they will distribute automatically. You can use, so I'm not going to get into that, but you can use something that's called pipe mode, so you can actually stream data to the algos. Okay, if you want to do this on SparkML, you would have to read the data. You would have probably to copy the data to your cluster for that thing to work. So you would import 100 terabytes of data to your EMR cluster. That's going to take a while, and then you would train. Okay, here you can actually stream the data to S3, so you can start training immediately, and you save potentially hours in this case. So this is built for one thing only, and that's machine learning. So the only focus is optimizing machine learning. So yeah, I'm pretty confident these algos are better than anything you'll find out there. But if you're interested in the benchmarks, I can give you the presentation to that. Okay. Yeah, sure. Yeah, I will add the link to the slides. So actually, let's look at the first example. So I'm going to use blazing text. And this is actually, this algo was actually written and published by Amazon researchers. So blazing text is about natural language processing, and you can use it in different ways, but here I'm going to use it in simple ways. I'm going to use it to classify text. Okay? So let's look at this. All right, so SageMaker, here we go. Okay, so I created a notebook instance. I opened, oh, I can show that to you. All right, so this is Jupyter, nothing new. And okay. Come on, Wi-Fi, don't die on me now. And these are the examples I was referring to. So they're automatically cloned to the new notebook instances. So this is also available on GitHub. The link is at the end of the talk. So it's a collection of, I don't know how many now, maybe 100 notebooks that show you all the different ways in which you can use SageMaker. Okay, so if you're just getting started, I would recommend this category, Introduction to Applying Machine Learning. These work with like real life or real life data sets. So how would you use, for example, XGBoost to predict customer churn? Or how would you use, how would you forecast time series, etc., etc. So these are interesting. And of course this one, Introduction to Amazon Algos, so showing you all the built-in algos that I just mentioned with many, many different examples.
One question.
Sure.
You just showed us that there's like a lot of different algorithms, especially for the models. But do you have any models for the feature engineering?
No. Feature, no, we believe feature engineering is something else. And SageMaker is really about training and deploying. Okay, so if you need to do feature engineering, you could do feature engineering in the notebook if you wanted. But again, at scale, that's not a good idea. So at scale, yes, you could. I guess you could use Spark. You could do Swift, depending on what your data looks like. You can do feature engineering here. Okay, so let's take a look at this. So here we're going to import the SageMaker. Can you read okay? Is it large enough? Yeah. Yeah, no, it's too large. Okay. So we're importing the SageMaker SDK. And we don't need much to get to work. We need an S3 bucket because that's where our data will be stored, and that's where we'll save the model. So we grab a bucket, and now we download the dataset. So we use this dbpedia dataset. So it has about 500,000. 500,000 samples. So 500,000 sentences in 14 categories, 14 classes. So we download that to the notebook instance, we extract it, and this is what the samples look like. Okay, so I've got a category number here, category 1, and then I have the sentence. Okay, and again, this is category 1, and this is the sentence. Okay, so the categories actually look like this. Okay, 14 categories. Okay, 14 classes. So I'm loading those in a dictionary because I will need that later on. And in this case, we don't need to do much pre-processing. The input format for Blazing Text is actually very simple. It just wants space-separated tokens. And a token is really, it's a word or a punctuation sign. Okay, so we need to make sure all sentences look like that. And here, for example, punctuation doesn't have a space before it here, so that needs to be fixed, etc., etc. So it's called tokenizing. So we're using an open source library called NLTK, Natural Language Toolkit, to do that. And we just call an NLTK API called tokenize. Just calling sentence after sentence this API and saving that. Okay, so very, very simple, no big deal here. Okay, so we pre-process the training set and we pre-process the validation set that we will use to score the algo. Okay, just again, the only thing we're doing is tokenizing, so making sure we have a single space separating words and punctuation in all the sentences. Okay, and it's quite typical of what you would do on your dataset. Okay, now I need to upload this to S3. Okay, because that's pretty much the only thing that SageMaker forces on you. Its data needs to be in S3. Okay, and I define the location of the training data and the validation data, so it's in an S3 bucket somewhere. I define a location for the model, where to write the model, okay? And that's about it. So a little bit of pre-processing and then copying the data to S3. All right, so I mentioned earlier this is all based on Docker. So, but the only thing we need to know is how to grab the name of the Docker container for blazing text in the region that we're in. But fortunately, we have a utility function to do that. Okay, so literally give me the name of the blazing text container in US East 1, which is the region I'm using. Okay, and here's the name. So as you can see, it is hosted in ECR. Right. Okay, so that's it. I selected the algo I want to use. And now I can set up my training job. And I use this estimator object from the SDK, from the SageMaker SDK. The first parameter is which algo to use. So the name of the container. How much training infrastructure do I want? So here I'm going to train on one C4 4XL instance. Okay. I'm using file mode, so meaning I will copy the data set. I'm not streaming the data set here. It's not big, so it's probably easier just to copy the data set to that instance. And this is where I will save the model. Okay. So that's it. Then I need to set some parameters for blazing text. And here, this notebook is a little too fancy. I mean, most of these are actually optional parameters. The only thing we need to say here is supervised, because we're working with a labeled data set. We want to build a classifier. So this is really saying that. And we're going to train for 10 epochs, so 10 rounds. And I think most of these are actually optional parameters. So unless you know what you're doing, I would recommend leaving optional parameters to default values. And you can read about that in the documentation. Okay. So for each algo, we'll have some parameters to set. Okay, and then we just train. Okay, so we call fit, passing the location of the training set and the validation set. And so this will create automatically that, what was it? C4 4XL instance. Okay. So it fires that up, pulls the XJBoost, pulls the blazing test container, inject your parameters, your training set, etc., and it starts training. Okay, so this is not happening on this instance anymore. It's happening on a managed instance elsewhere. Okay, so it trains for a bit. We see the log. So it trained for 47 seconds. Our training accuracy is 98.69%. Our validation accuracy is 97.2%. So, you know, surely we could do better if we tweaked a little bit, but okay, for this example, it was more than enough, right? So it's interesting to see, you know, 500,000 sentences, you can train a classifier in 47 seconds. Yes?
Is there any tool to estimate what time it's going to take the training, depending on your data set?
No. I think it would be hard to figure out. So
anything like TQM, like a progress bar, so that you can stop it if you don't.
oh, you can, yeah. So here I'm working in a notebook, but obviously, if you can see those jobs here, training jobs, yeah. So if you realize, okay, you launched it and it's painfully slow, and because you underestimated, you know, the complexity, and you want to relaunch it with more, you know, bigger instances or more instances, you can just go and click and stop it here. It will kill it, and you can start something else. Yeah, sure. And by the way, this log here is also pushed to CloudWatch. Okay, so you don't have to actually, you know, if the notebook, you don't have to look at your notebook, right? And again, I'm using a notebook here, but I could just use the SDK from an application, so that wouldn't be a notebook at all, right? But the log would still be in CloudWatch. Okay, so here I paid for 47 seconds for that instance type. Okay, so let's say I'm more than happy with the accuracy. How do I deploy this? Just like this, one line of code, like I said. Deploy that model to one M4XL instance. So again, it creates it, pulls the model, pulls the container, loads the model, and creates the HTTPS endpoint to predict. Okay. if I was deploying to 100 instances, I would just do this, right? And it would create 100 instances and load balance them, etc.
It depends, accuracy of the result depends on how many instances I will start.
No, the accuracy here really, it depends on how you, well, I guess it depends on the quality of the data, but here it's pretty good.
But if I repeat this test a few times, I will receive.
Oh yeah, if you sure, yeah, you generally you will see the same thing. So so if that's not good enough, if you need to iterate,
Yeah,
so
I know if I want to, as I understood, I want to increase accuracy, I should add some new data or some parameters.
so here I would say in the specific example, I think we have more than enough data, right? Because we have, let's say, we have about 50,000 samples per class, pretty much 40,000. So, you know, it's probably enough.
Yeah.
So if you need higher accuracy, then you have to dive deeper on those, start tweaking, and that sounds scary, right? So wait for 10 minutes, I'll give you the magic answer to not losing sleep over that. Okay? So we deploy and then we can predict. So take a couple of sentences, tokenize them. Okay? So make sure I've got this single space thing. And then I can call the predict API, which will really HTTP post to the endpoint I just created, right? And if you want to use, I don't know, curl or a postman to do this, that's more than okay. You can grab the URL for that endpoint. It's, for example, here, right? So it's an HTTP endpoint, right? So if you post data, you get back a prediction. Okay, so you can use your PHP app here if you want. Why not? Okay. And I can see some responses. So the first sentence with very high accuracy is about companies. Okay, but it's really cheating here because we have the word company in there. So, right, we should say this and run that cell again. Okay, so yeah. Still pretty high on the fact that it's a company, right? And college, yeah, this says college. So again, with a high level of accuracy, we know it's an educational institution. Okay. So that's it, and then we could delete the endpoint and and shut down that prediction endpoint. Okay, so as you can see here, it's really not machine learning at all, right? We downloaded the dataset, cleaned it up a bit. We set up our training job using the built-in blazing text container. The only thing that we would need to pay a little bit of attention to is probably this. Okay, what are the hyperparameters for this algo? But look at the documentation. And again, my advice is stick to the required ones. Okay, ignore the optional ones. Okay, and see that gives you a baseline. If the baseline is good enough, then fine. Okay, job done. Deploy, move on to the next thing in your to-do list. If the accuracy is not good enough, then as this gentleman said, yeah, probably we need to tweak those to get higher accuracy, but this doesn't look friendly, so I'll give you the answer in 5 minutes. Okay? Questions? No questions? All right, so this will work the same for all the built-in algos. You will see that workflow every time. So use the estimator, set hyperparameters, call fit to train, call deploy to deploy. All the notebooks look the same. So you learning the SageMaker SDK will take approximately 2 hours. Okay? Because it's not the complexity is not there. Okay? Not at all. It shouldn't be. So and there's no infrastructure at all. Did we worry about infrastructure much? Okay? Well, your point was good. I mean, it's like if my job is too slow, can I shut it down and try something else? Yeah. If you want to do distributed training, there's nothing to set up. Just say, give me 5 instances, it takes care of it. Okay? So the point is, you can iterate quickly on training, evaluating. Okay, I tried this algo, now I want to try another one, and ignore any plumbing concerns. So what about deep learning? What about TensorFlow? What about everything else? So I'm going to show you a TensorFlow example, but before somebody asks me what's the difference between this TensorFlow and the other TensorFlow, we actually have a dedicated team working on optimizing TensorFlow on AWS. Okay, so we had a couple of blog posts. This one shows 5x to 7x speed up on training image classifiers. So comparing our optimized version of TensorFlow versus vanilla TensorFlow, right? As in, pip install TensorFlow. And this is the more recent one on an 11x speed up on C5 instances, again, training. Okay, 11 times faster. That's very significant because it means in a single day, even if you're working with large data sets, you can iterate 11 times more.
On the same instance, right?
Yeah, that's the same hardware. Vanilla TensorFlow on C5 compared to our TensorFlow on C5. So if your job took 2 hours before, okay, so let's say 120 minutes, okay, now it takes about 12 minutes. So in the same day and in the same budget, you can run 11 more times jobs. So you can experiment more, you can optimize more, and you can get quicker to
just have some rest.
Oh yeah, or you could go home. You could go home 110 minutes earlier.
Usually that's a good
But since all you guys are here, I mean, I know you're freaks, so you would just use the time to work more.
Yeah, but that's usually a good excuse. Well, my model is training. So
Yeah, it's like my code's compiling, so now you don't have the excuse anymore, right? But probably what I would do is, within the same budget, try 10 times more things. Okay. So let's look at a TensorFlow example. So I'm going to show you how to train on TensorFlow, and I'm going to show you that elastic inference feature, which I think is pretty cool. And you will get all the slides, right? Don't worry. I see you taking pictures, so yeah, relax. You'll get everything. Focus on my voice. Okay, so this is a fun example. So the crazy business problem we want to solve. Who has seen this before? Yeah.
Iris data
Yeah.
set.
Okay. So this is a data set to classify the iris flower, because as it turns out, there are 3 types of iris flowers. You all knew that, right? Okay. I'm not sure they grow in Ukraine, but okay. So the data set actually looks like this, right? So you have 4 features, and you have a label, 0, 1, 2, okay? So this has 150 samples. You could say, wow, that's really tiny, right? Do you know where this data set was actually put together? All right, let's play the game. Nothing to win, but come on. Machine learning. Come on, take a risk. No? Who says after 1980? Ah, you're suspicious now. Okay. The answer is 1936. Yeah, this is probably the oldest machine learning data set out there. Okay, 1936. Okay, so we'll keep 120 samples to train and 30 samples to test. Okay. So this is a simple classifier, and you could write your. Let's look at the. Okay, this is the TensorFlow code. So a very simple neural network to classify those things. Okay. So if you don't know TensorFlow, don't worry too much. As you can see, we have 3 layers in that network, so we have the input layer with 4 features, and then we have 10 neurons, then 20 neurons, then 10 neurons, and the output layer will have 3 neurons because we have 3 classes. Okay, so input layer, output layer, 3 layers in between. Okay, so it's TensorFlow stuff. You could copy this code to your laptop and run it as is. Okay, so this is vanilla TensorFlow. No changes required to to train on SageMaker. Okay? So that's actually my TensorFlow script. Okay, so what do I do with it? So this is just the same one. It's going to be very disappointing, right? I'm going to use the TensorFlow object in the SageMaker SDK. I'm going to pass the script as a parameter. Okay, I can choose the TensorFlow version that I want, where to copy the model, where that script, if we have a custom directory for that script, we can pass it here. And then once again, we're going to train on one C4XL instance for 1,000 steps. That's it. Yeah.
Is that model compatible with the regular TensorFlow? So it's
Oh yeah.
Oh, so it's
Oh yeah. I'm showing TensorFlow, but if you use PyTorch or something else, it's the same.
No, I mean like the optimized one we have.
You can take that code.
Full compatibility, yeah?
You can take it to the bank, as they say. It's there is. I would say if you write ugly TensorFlow code, not following the guidelines, okay. So if you don't have the train input FN and all those, best practice functions, it might not work on SageMaker, okay. So if you write it well, it's going to work on SageMaker. So you write it well in Ukraine, I'm told, so it's going to work. Okay, so that's it. It would be exactly the same for all the built-in environments. Okay, so it's as complicated as writing this. Okay, just taking the object and passing the script and saying how much infrastructure you want. So if somebody tells you, oh, it's going to be painful to move our on-prem TensorFlow training code to SageMaker, find something heavy and you know what to do with it. Okay? Like I said earlier today, humans are great at finding reasons not to do the work. Okay, so heavy objects help. And then we train, okay? Passing the location of the training data. And well, we see stuff going on. Okay, do we have the accuracy somewhere? Yes, 96, here it is, 96%. All right, we'll take it. And we trained for 37 seconds. So that didn't cost much. Okay, so I could deploy just like in the previous example, okay? Dot deploy, blah, blah, blah. Let's say I need GPU acceleration for this model, okay? So I actually don't need it, right? But like I said, I'm not paying my AWS bills, so I can do silly things. But let's say this model actually benefits from GPU acceleration. So you can say, well, no problem, right? So I'm going to look at the SageMaker documentation. I'm going to find the instance type. So maybe it's going to be ML P3 to XL. I deploy to GPU instance, just like that. Life is good. I can go home early. Yeah, okay. Now the problem is, I'm more than happy for you to spend your dollars on AWS, but I really would like you to spend your dollars in the most efficient way possible. So maybe, yes, maybe the model benefits from GPU acceleration, but maybe a full GPU instance is a little bit too much. So it's like, come on, I really don't know what I want, right? I want GPU acceleration, but I don't want a GPU instance. So should I go back to the CPU instance then? Well, okay. So there's a middle ground, and that's called elastic inference, EIA, elastic inference acceleration, where you can actually deploy, and this works on EC2 as well, if you want to do it manually. You can deploy on a CPU instance, but bring some GPU acceleration. Okay, so you have three sizes: medium, large, extra large, right? Like Burger King. And so you attach a fraction of a GPU, if you want to see it like that, to this instance. Okay, so you get good enough performance, but you save probably 70% of the cost compared to a GPU instance. Okay, so if you need, from a cost perspective, the only one thing to remember tonight is if you're deploying to GPU instances and you haven't tried elastic acceleration, elastic inference, you're probably wasting money. Okay, so please try this, and if performance is not good enough, then okay, move to full GPU instances.
How does it work in the background? Is it like
You're asking me?
It's like some GPU sharing across different, you don't know. But actually why I'm asking this, let's say, will it be guaranteed that, let's say, the prediction time will be the same on...
So yeah, so we actually give you a performance indication on medium large and X large. So we give you, how many teraflops you should expect, etc.,
okay,
etc.
so there will be, let's say, even during the peak hours.
Yeah. So but it's dedicated, right? So
Okay.
everything is dedicated. So this level of performance is constant any time of day or night, and you know how many teraflops that is. Okay, and I forgot because I think medium is 8, but I forgot. Okay, so now deployed, and I'm running prediction on this instance, but there is some fractional GPU attached to it. Okay, again, this will save you a ton of money. Okay, and again, now I can predict, so I can pass the 4 features. And it tells me the likeliest class is this. So this is a class 1 iris for what it's worth. Okay? And if I change, I don't know, whatever, just run that again. Oh, it's still a class 1 iris. Okay, so simple. And I could delete the endpoint when I'm done. So again, you see, same workflow, configure the job, train, deploy. In this case, optimizing cost with the accelerator. Okay. All right, a couple of more things and then I'll be done. I still need to answer your question on not having bad dreams with hyperparameters. Yeah. Hey, here we go. So. Okay, so you're convinced. SageMaker is great. You go back to the office, you start experimenting, you keep all those optional parameters hidden because they look bad, and but still, you train, and exactly where we stopped that discussion. You get to an accuracy level that's kind of okay, but you want more, right? For your AWS dollars. So the problem that you want to solve is this: finding the optimal set of hyperparameters. Okay, let's say we have 10 hyperparameters. We need to find the best values for those. So that means the values that will give you the highest accuracy. Yeah, that's what we want. Okay, so the first thing is manual search. So you're going to start adding those parameters to Notebook, and you're going to try some values. The doc gives you reasonable ranges, so you're going to explore. Okay, so this is what I call I know what I'm doing. Okay, and no offense, but you don't know what you're doing, right? I don't know what I'm doing, and no one here knows what they're doing, even if they've been doing machine learning for 10 years. It's impossible to figure that out. Okay. You've seen that movie, Interstellar? Well, if you haven't, sorry, I'm spoiling the end. Okay. So you get trapped. Yeah, because I like to do that. Do you want to know about Game of Thrones? No? Okay. So you get lost in that multi-dimension space, right? And you're trying to find out how that works, okay? So it's same here. If let's say we have 10 hyperparameters, so that space has 10 dimensions, and we're trying to find the optimal spot in that 10-dimension space. Okay, I told you would need caffeine, right? So you could do grid search. So you could create 100 combinations for those parameters, run 100 training jobs, hoping that some part of that space yields higher performance models. You say, well, that part of the space here, those nearby data points, they tend to be interesting. So I'm going to restrict the parameter ranges to that part, and I'm going to create 100 more models, zooming in, right? Galaxy, solar system, etc., right? Exactly that same story. Zooming in space, training 100 models, and maybe zooming in a few more times. Hoping that by zooming on the interesting parts, I get to something that's really good. Okay, so you will end up training hundreds and hundreds of models. Okay, so if each model takes 15 minutes, takes a while, right? And so it's slow and it's expensive. Another technique is a random search. I call that spray and pray. So there was a research paper in 2012 that actually shows that random search generally works better than grid search, which is very disappointing if you're an engineer, okay? So you just create a few, maybe 100 jobs, with pretty wide ranges, and you just pick the one that works best. And on average, it's faster and cheaper than grid search. Yeah, I can share the research paper if you want. So okay, you save money, you get there faster, but it's random. So now imagine going to your boss or your customer, right? 20 people around the table. So Mr. Engineer here is in charge of the ML project, and you're going to explain how you came up with that 98.5% accuracy model. So what was the thought process? Well, I took 100 different combinations, trained at random, and I picked the highest one. Yeah? If you can pull it off, man, congratulations. Okay? Good luck explaining to them that it is actually the better option. And maybe you saved thousands of dollars on not training with grid search. You did the right thing, but it's a hard sell, right? All right. See, I'm not only picking on you now, I'm picking on him as well. And so what's the best option? The best option is to use hyperparameter optimization, which literally uses machine learning to find the best parameters. So the way this works is you will still define parameter ranges, and you'll tell SageMaker, okay, train 30 jobs, 3 by 3. Okay, so it's going to train 3 jobs. So that gives it 3 data points, okay, matching hyperparameter values to accuracy. And it's going to apply machine learning optimization to those 3 points in order to predict the next 3 combinations. So they're not chosen at random. They're chosen based on fascinating algos called GPR and Bayesian optimization. Right? If you really want to ruin your evening, go home and read about those. Okay? So it's going to predict the next 3 set of parameters. Okay, and you're going to train on those 3. Okay, now you have 6 data points. And you run the same process. Okay, 3 more data points. You've got 9, etc., etc. And gradually, you will actually get to high performance models by doing that. And you will end up training probably 10 times less models. So it's a huge, huge difference. And now you have a scientific process to explain to your boss or your customer. Okay? So HPO works very well. So I'm going to show you really quickly how to set it up. It doesn't really matter what we're training on here. I'm using TensorFlow. Okay, so it's the same as before. I set up a TensorFlow training job, exactly the same. Okay, looks like this. But this time, okay, here I keep it simple. I want to optimize on one hyperparameter, the learning rate. Okay, so I want to explore values between 0.01 and 0.2. Okay, so I'm going to train. I'm going to optimize on this. The metric as I want to measure is loss or prediction error. Okay, so of course I want to minimize it. Okay, either you want to maximize accuracy or minimize loss. Okay, so I create this hyperparameter tuner object, passing the job that I set up earlier, the name of the metric, the ranges, etc. And here I'm going to train only 9 times, 3 by 3. Okay. So I'm training, okay, and if I look at the console, I will see, so I could explore while this is running, but I run this before. So I see my 9 training jobs, okay, using different combinations, and I see the actual metric here. So obviously the best training job, and you can look at this one, right? I'm trying to minimize error here, okay? So you can see, the first few ones are like, okay, apparently we're not really looking in the right place. We're not making a lot of progress. And then once we have 5 data points, bam, we hit a spot that is really much lower than the previous ones. Okay, and the next one is kind of okay, a little bit more. Then okay, we make a totally wrong decision here, and then the final one is really we hit the jackpot. Okay, and so, whoops. And you could see in this case, so the best job is the last one. So probably we'd be tempted to explore a little more. Maybe if we keep training for a few more jobs, we'd get even better. And this one was a learning rate of 0.010206, which I don't think is a value any of us would have tried. Yeah? Yes?
Is there an option to set the cross-validation items? Because otherwise you might just overfit.
Yeah, that was the same question. Isn't it overfitting?
No, it's not. All these jobs are different ones, right? We start from scratch each time, okay? So we don't train the same thing 9 times in a row. These are 9 different trainings.
But the data set, do you use the cross-validation data set?
No, in this example, no. You could implement it if you wanted, okay? You could implement it if you wanted. Okay, so here we're just trying 9 combinations, but okay, it's one single parameter, but I have other examples with 3, 4, 5 hyperparameters. They train a little longer, but you know, this will get, you know, to higher accuracy automatically. You know, if you have bigger jobs, maybe you need to train for, some jobs will train for 4 hours, 6 hours, 9 hours. You just don't worry about it. You let those things run, and you just pick the best model at the end and deploy that one. Yeah.
Is there a research paper or some blog post about what's under the hood?
Yeah, if you look in the SageMaker documentation, they point you at the research papers that they use. Yeah, but it's like I said, GPR and Bayesian optimization.
Can we specify, for example, how many correct answers should be and how many wrong answers should be in the result? I mean, value and
I get it. So no, the target is the number of jobs. So actually, it would be nice to say keep optimizing until you get to this accuracy, or maybe you train 100 times. Yeah, it would be nice. Good idea. Feature request. Thank you. And we'll call this one the Ukrainian way. Okay, last thing, and then we stop. Model compilation. So you optimize, you have a fantastic model. It works super well on EC2 instances. And then somebody comes and say, oh, we're moving into IoT, and we need to deploy it to ARM-based platforms, and like we need to deploy to Raspberry Pis, right? Yeah. Oh yeah, sure. I'm just done. Okay, 2 minutes. So model compilation. How do we train that model? We tried it on the Raspberry Pi. It's super slow. So what do? Do you need to train a smaller model that will run better, etc.? So we came up with that service called Neo, and literally it's one API call to compile your model for a given hardware platform. So it's going to generate hardware optimized code, so native code, to speed up your predictions. Okay, so it works for most of the libraries that we support, and this is how you do it. So you write a simple JSON file saying, okay, here's my model in S3, so that's the output of a SageMaker job. This is the input shape for the model, so if you had trained it, you would know what's the size of the input layer, so let's ignore that for now. This is an MXNet model, and so compile it for Raspberry Pi, so ARM architecture, and let's output to this bucket. Okay, that's it. You compile the model to like this, create compilation job, wait for a few seconds, get the compiled model from S3. So you have your initial model, and you have the optimized native version, and then copy all that stuff on your Raspberry Pi. And we don't just support Raspberry Pis, we support other architectures. It's just an example. And then you would use the Neo runtime, the deep learning runtime, to load your compiled model and predict. Okay, so I'm talking about Raspberry Pi because I actually tested it on my Pi. For complex computer vision models, I get 10x speed up. Okay, so I'm not promising 10x for everything, but it is it is quite fast. So you can optimize for ARM, Intel, NVIDIA, and we have other platforms coming. So this is open source, so you could actually port it to something else. Okay. So let me, okay. So resources. So the free tier I mentioned before. So SageMaker is part of that. ML.AWS, the SageMaker page, the Python SDK that I used. It's on GitHub. The Spark SDK, which I quickly mentioned. All the notebooks that you saw are also on GitHub. I did a successful workshop at reInvent. So it's a very long scenario using XJBoost, going through everything, training, optimizing, etc. So you can find that on GitLab and you can run it. And again, the Medium blog and some of my own notebooks on GitLab. Okay, so if you're just starting, again, please go to this and look at the Amazon Algo and Amazon Algo notebooks and run those. Okay, and you can run them on a free tier. You don't need much. These are small data sets. You won't blow the free tier up with those. Okay. All right. Thank you very much.